The next generation really wants to do cool stuff. I think the open source movement will allow us to train more intelligences, better intelligences, and I think that is the key to unlocking robotics for everyone.
Hey everybody, welcome to Beyond the Bench. I have a really special episode for you all today. I'm joined here with Dhruv, founder and CEO of Get Solo. How do you think about real robotics setup? You're going to be using VLA for control. What are you seeing, like the real-time capabilities right now?
The main technological change in doing this is instead of having a large model that knows multiple domains and quantum physics and cooking, you have a model.
Could be some interesting popcorn.
Yeah.
So what is a RoboGym?
This is something that I think we all dreamt of watching Baymax. I think RoboGyms will allow people access to.
Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Hey everybody, welcome to Beyond the Bench, Hardware Stories That Matter. I have a really special episode for you all today.
Yes.
I'm joined here with Dhruv, founder and CEO of Get Solo. Dhruv, welcome to the show.
Hi. Hey everyone, thank you, Bill, for having me. I'm founder of Solo Tech, and we're available through getsolo.tech, and happy to share more about our work in physical AI.
Oh yeah. So VLAs. Tell us what is a VLA model?
Yeah, the VLA is the keyword of the month, especially in robotic circles. So VLA is vision, language, action model. So you might have heard of LLMs and VLMs, which are predictions of language tokens. VLAs are predictions of actions. So they predict like motor action or actuation. And these are models that can be used to train and do actions with robots.
And so these models, you're giving it a scenario and asking for what the robotic control should be as an output.
Yes. Well, how these model train is they train on looking at an image and making a prediction of what the motor stage
Okay.
could be based on that image. So, and how you train them is by doing imitation learning. And basically, what that means is you teach a specific motion to the robot. Like when it sees a cup, it should move to grab it, and then basically the model encapsulates the series of motor movements to perform a grab, and that is what is stored in a VLA.
And so we're seeing a lot of new activity in the robotics space. I follow it heavily on social. These VLAs are a major unlock, correct?
Yes. And the most interesting thing is we're still at the ChatGPT 3 stage of these VLAs. There's a huge opportunity and unlock like smooth motion or making motion like super efficient for wear and tear. So, how do you make these robots behave in a way so that, they need less maintenance? Yeah, there's a lot of greenfield work there. And also currently these VLAs that are available are only able to capture like small motions.
Okay.
And then the next generation that you're expecting in 2026 will do multi-turn. And that's also something that is very exciting.
So we were working with Get Solo yesterday on a robotics project that we're building for an upcoming expo. And I learned a lot just even being in the room and talking through how you're recording and training and even how you are performing the actions during the training impacts how the robot will move. And so we were very careful to not do things necessarily exactly how a human would like to do it, but maybe what's more efficient for the demonstration or the wear and tear on the robot, limit jitter, etc.
Yeah. Yeah, the physical world is quite brutal, and you have to know the constraints of your problem and make sure visually you're able to discern objects. And um, yeah, I think it's a huge opportunity for people to start getting into visual transformers and these systems, so that we can have better like visual reasoning. And what many people are saying is basically going to unlock physics and a lot of like logical thinking. Basically, having visual reasoning and like physics based visualization. So yeah, big unlocks coming with this as well. Yes.
And so you guys integrate very closely with Hugging Face and a few other platforms. Talk to me about what's available in the model ecosystem today and how you work with your customers to make that usable on the desk or on the car, whatever.
Yeah. So yeah, it's such an interesting time. There's so many target hardwares, from ML SoCs to NVIDIA GPUs and NPUs and so on. And then on the model side, there's LLM, there's audio models, diffusion models. So what we do is we take the best of open source models and then we tune them for physical AI use.
Okay.
So for different domains, it could be a different model. For example, we know that Llama models by Meta are good for language translation because they already come with those skills. So if you want to do local translation or transcription, maybe use a Llama 1D model. Compared to that, there's other open source models. You can talk about VLAs, like small VLA, and ACT, like ACT by Stanford. Those are a different category of models, and those need to be tuned more on the action
Okay.
of a specific domain. So yeah, and what we offer as a platform is we partner with the best in hardware and these models and try to tune these models for specialized domains and make them available through our open source repos.
So, you guys have a couple products. There's the solo inference server. There's also the consultative training program, and then these gems. Like, how do you actually work with your customers?
Yeah, so the main idea, what we're trying to build is this library of models that you know people can just download and one shot into most activities.
Okay.
um, how we partner is basically we understand with our partners like what is the scope of their project. Like, do they need a very fine-tuned extensive model, or is this something that they can work with our platform with? And basically once we know those constraints, we allow them to either use our platform to fine-tune these models based on this open source models using our proprietary recipes and eval, or if it's like a very extensive project that requires multiple models and orchestration of that, then we personally work with them, assign like a partner engineer, and basically figure out the hard problems of deploying these models on the edge with them. Yes.
So for our demo, we could talk freely about that because this could be an expo. Tell me a little bit about that stack and like what's solo, what's not solo, and yeah, how you evolved that project going.
Yes. So, even the robotics industry is going through this transition where some things are raw, some things are Python, something is a model, and something is code. And how we worked on this demo is to basically use the functional parts of VLM and VLA to combat the fuzziness of physical movement and physical context,
Okay.
and use traditional Python to basically do inverse kinematics or basically do the scene understanding to perform this demo in which we are going to be sorting and delivery candies.
Um, so like what about the next phase for us? So we're working with the inference servers, we've got the image detection, that works, and then the next phase is training. So that this while it's a conference expo, I mean picking and placing and sorting things is like industrial viable, like very important activities. So like what does the actual like development of the model look like from here? We're not going to just be able to pull Hugging Face, candy selection, sorting model from the internet.
Yes. So, and candy selection and sorting is actually an open dexterity problem as well. So, this is like novel work that is being demoed at this event. So when we defined this demo, we compartmentalized it into different components. There's a vision component which is telling how to what to navigate to and what to pick up, and then the VLA part is basically the robot movement. And for that, yes, there does not exist a readily available data set that will pick up a robot currently, which is why we spend time with the team to create data sets of that robot moving, teleoping to pick up a candy and a variety of candies. And then once we have this data, we're able to put it into a VLA, train it into a VLA using a solo server, so using our repo. And once it trains on enough of good instances of good episodes of things picking up, basically these VLAs allow the model to infer with more reliability than traditional pickup or traditional path planning
Yeah.
robot algorithms.
And so we're going to be able to just throw a bunch of candy on the table and the robot will be able to act. And so in a traditional scenario, you have like a conveyor line with like beakers and stuff, and the robot is all controlled. But this is going to be visual recognition, get the red candy, put it on the conveyor. And this is like bleeding edge. It's crazy that, and like, you don't know robotics, and like me at Peridio, we're software people, and the amount of work that we were able to get done in just a few hours was like truly mind blowing.
Yes. And that's exactly the kind of development we want to empower.
Yeah.
We believe, the future is model primitive, and we'll use
Yes.
very impressive operating system to make those models actually do things. So we want to solve for, the model engine, the hardware SDK, so that we figure out the right model for the task. And, this sort of partnership basically helps embed us into like a real world demo with like actual value. So I think that's the, real magic of doing this together.
Yeah, absolutely. So you have a really interesting background. You haven't been in robotics your whole life. So like, how did you find yourself here?
Yes. So yeah, I haven't been a roboticist, but I've always observed from close enough. I decided to be a computer vision engineer because I always thought it's more interesting to work on some real world systems,
Yeah.
like car license plate detection, or some object detection, surveillance, or video geometry. So these are always very interesting problems to me, so I always worked on them and stayed close to ML ops and on device deployment. And then in the last few years specifically, I saw a huge value unlock for on-device AI, for models that can be used locally for, Industry 4.0 or agriculture and all these domains. And robotics needs that right now.
Yeah.
So I'm coming at this from a traditional computer vision machine learning point of view, but realize that, this new breed of AI based VLMs, VLA is critical for robotics deployment. And yeah, that's what basically Solo Tech is based on, ensuring that, these on device and local and performant flows we can really unlock and basically fulfill the promise of edge compute or IoT and all these wonderful things that folks have been working on for the last decade. Yeah.
And so where are we right now? Like this, like we'll talk about your office in a second, but like we're in the heart of Silicon Valley. Place is called Circuit Launch. What's the significance of where we are in this moment?
Yes. So being here is actually one of the key things that helped me on board into this robotics domain as well. So, the Circuit Launch is a mechatronics and robotics co-working space. We're right in front of NASA Ames and right behind Waymo. And this used to be
Samsung's research
Yep,
is like
Samsung
right. You
research,
could throw a rocket at it. Yeah.
Canon lenses, right there. So yeah, it's really like sacred ground
Yeah.
for roboticists, and Boston Dynamics used to be here as well. So yeah, so this space allows you to connect with other roboticists, other motor companies, other you know uh, rovers on the moon companies, and then learn from them, and then basically bring in this like model first way of looking at robotics with the leaders in this. So yeah, that's the advantage of being at Circuit Launch. And yeah, happy to be part of this and happy to have you here, and your team is welcome here. And specifically this room, which is the AI and robotics gym, is dedicated to robot training. So yeah, happy to welcome folks here if they're interested in training their robots.
So what is a robo gym?
Yeah. Well, I think this is something that I think we all dreamt of, like, watching Baymax and all these movies. But I think it'll be a key idea of the future. Just like how internet cafes took over, giving people access to internet in the early days. I think robo gyms will allow people access to this expensive robots and hardware that it takes to build these systems,
Yeah.
and basically allow access in an open source way so that we can have more democratized intelligence, more democratized robots, and do this thing with observability, with the community, instead of just a few um, companies doing it in research labs. So I think the AI and robotics gym is an idea for the future, and I'm looking forward to having more of these in many places, to empower people to learn robotics and AI and train their robots.
And so, what does it mean for a robot to come in here and work out?
Yeah, well, we are currently working with the open source SO101 arms, and
Pick it up.
yeah, and we train them for like cooking tasks.
So this is the
Leader.
leader arm.
Yes.
And so you have a leader which drives it, and then you have the actual arm.
Yes,
And so these will be in coordination. We will not coordinate our movement. But
kind of like that.
yeah.
And so that's what we're working with right now. But we're looking forward to having more NVIDIA hardware, NVIDIA Thor, as well as open source humanoid robots here as well.
Nice.
So we're going to be doing some activities which require maybe, one day, like real steel style training a robot for a fight.
You have friends that are doing that right now, right?
Yes.
Yeah.
We have our partnering organization in San Francisco, based out of Frontier Tower. They organize the boxing through UFBs. So it's one of the fun things of being in the Bay Area. You get to enjoy this. Yeah.
So we'll have to get Rory some clips there of the
Yes.
UFB.
Yes. 100%.
It's unbelievable. So can you share anything about the types of companies that you're actually working with here? Anybody that you're able to publicly disclose?
Yeah, I think well, we're surrounded by partner companies, but some key partnerships that are shareable and very special are, basically starting the year out with autonomy. They have multiple delivery robots, across airports and factories. They're kind of leading the way with the intra logistics robot delivery, and yeah, we were able to put multiple fine-tuned VLMs on them so that the robot can tell between mall lobby and hospital lobby and how many people are there in real time. So yeah, those are some of the partnerships we worked at, and then more recently we're working with Ollie Robotics, Feather Robotics, uh, a bunch of these like humanoid companies, um, to help train VLAs to perform tasks around the house, packaging tasks, things like that.
So there's a lot of work on the foundational side right now, and obviously lot of money is going towards this. NVIDIA, incredibly strategic, is Edge AI, and specifically robotics and computer vision's actually what they're calling it now. Even Edge AI is
Physical AI.
yeah, Edge AI is very 24.
Yeah.
We're into 25 right now, so it's physical AI. Who are the foundational model companies, those that are putting things out in the robotic and the open source robotic space that you're paying attention to right now?
Right. So NVIDIA has their own Groot models.
Yeah.
They're great, very foundationally trained, extensively. So I think that's a great family of models. Hugging Face has small VLA.
Yeah.
Uh,
And they own this design, the Lego.
yes, the little pod design is, they're promoting that, and everything related to that. And physical intelligence is
Yeah.
also a key player in this.
They're so cool.
Yeah,
Yeah.
with the really cool models, especially the Pi Zero Fast. It's able to fine tune quite well, and we're looking forward to Google Robotics releasing their 1.5 model, and I think 2026 is setting up to be a great year for robotics models.
I was working with one of the Google models with Z on some of our early POC, and the Google model, the VLM, is like fantastic. So small, so performant. It is the, how do I say it? Gemma? What is it?
Gemma.
Gemma?
Yeah.
Yeah.
Yeah. Yeah, Gemma is quite good. We have used it in multiple applications as well, especially for mobile, form factor. Yeah, when Google, their team is coming up with their models. They're not as aggressive as some other companies, but when they put something out, it's Google standard.
Yeah.
It works. It works in multiple scenarios and deploys as expected.
Yeah.
So yeah, I think those are some good things coming out. But yeah, powering open source models, I think, is going to be the way forward with this. Yeah, with this momentum.
I was listening to an interview, and I remember it was in a podcast. I was at a energy conference last year in Anaheim. Interesting. And it was just a year ago, and Eric Schmidt was talking about how it was computationally prohibit. Like, of course, we use these models on the edge, but people actually can't do this stuff in practice. 12 months later, that's not the case anymore. I mean, it is not too expensive to do these things in the field. You don't need cloud connectivity. You can power it with real LLM derived technologies.
Yeah, yeah. I think people are realizing how expensive it is to have GPU AI.
Yeah.
And even if you are able to figure it out in a scalable way, how do you get ROI from it? And these problems become very real in physical AI and robotics because you really want your model to work at light speed,
Yeah.
literally, and you cannot waste bandwidth or network on sending multimodal data
Yeah.
and getting predictions on it. So I think there's a natural gap that even the hyperscalers want to address with some edge cache models,
Yes.
like edge hardware. So I think there's a whole wave of embedded AI waiting to happen, and I think yeah, there's going to be a lot of interesting ideas coming out from that. Yeah.
So what's the on compute and cost? We were discussing like number of inferences you can make in a second across these different models. I mean, you have to be deeply aware of what you're running in the field, right? And so how do you think about a real robotics setup for like what we're working on? We have Yellow for like the initial image detection, but we're
Yeah.
going to be using BLA for control. How frequently do we query the model? How do we think about that performance? What are you seeing like the real time capabilities right now?
Yeah. So I think the real trick comes from knowing the scope of what is going to be the usage of your model. That really helps you uh, figure out, how lean you can go on the performance.
Okay.
So I think the main technological change in doing this is like, instead of having a large model that knows multiple domains and quantum physics and cooking, uh, you have a model.
Could be some interesting popcorn.
Yeah, 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 exactly. Quantum popcorn. Uh, but instead of doing that, because the physical world and because robotics needs performance,
Yeah.
you're forced to really have very tuned models which don't hallucinate as much and basically need things real time. So if you're able to know the scope of that, you can actually have real time working YOLO models and real time working VLAs and VLMs to offer like smooth contextual robotics. Yeah. So
Cool.
yeah, that's like once you have the scope down, I think having quantized models and figuring out the right inference engine and the hardware config, that part we are taking care of in Solo Server. But yeah, once the domain of the model is just supposed to do this, 3 tasks or so on, then we can really hone in on like maybe even having 100M model that really responds to your set of expected questions
Yeah.
and does that reliably, performant, without cloud, without confusion. And that's what we're trying to go for.
So near and dear to my heart, the hardware config. So Peridio, Avocado Linux, we focus on silicon first integration. and working with the leaders in the space. Obviously, NVIDIA is key. What are the what are the what are the devices that you're seeing being deployed? Is it the Orin Nano, AGX? We can use so much. We want to go straight to Thor, or there's also a lot of other silicon vendors getting into this space. Like what are you seeing in practice?
Yes. So yeah, I think there's a lot of, well, Nvidia is great at this, and we have a bunch of Orens here. We're also in the Inception program, so that helps with the partnership, and soon we'll be having the Thor. So I think these are great systems that work right now.
Yeah.
There's an incoming wave of MLSoCs and even Raspberry Pi compute tops, and stuff out of Qualcomm that is, I think, going to really give it competition, especially with the power.
Yeah.
I think you can get away with a lot of compute on NVIDIA systems, but you need to balance it with how much battery usage and what that robot is going to end up doing. And these models are currently heavy, so you kind of have to make that choice of, like, fast model, reliable, but for a short time, or something really running on a Raspberry Pi, but it can run all day without any issues. So yeah, but I think 2026 we'll see AI native hardware
Yeah.
come out, from, as you said, from the silicon perspective, and that will really unlock, these applications that we expect in Industry 4.0 robotics and these, inference at the edge platforms. Yeah.
So I'm gonna hard pivot, and we're gonna do like a little lab tour here in a second. So forgive us, this episode's gonna run a little longer than the typical 30 minutes. Um, One thing that I really appreciate about this space and you in particular, there's a really nice like age diversity here, and so there's clearly folks from NASA in the building with gray hair and crazy ideas and have done like really amazing things. But you're also bringing in the next wave, and you got a lot of interns here. You also have folks dropping in after high school, and so like full spectrum age gap. This is not like the 27-year-old Adderall ridden cracked agent developer. It's really full spectrum, and it's really interesting to what are you saying as far as like people who are getting into this space?
Yeah. Well, I think many software people realize this, and now roboticists know it. Like, when you see something move in the
Yeah.
real world that you've programmed, it's different.
Yeah.
It's just different. Like, seeing something on a screen doesn't do it. I think everyone's first teleop session is so special. We've had a few events here which allow that. And yeah, I think it's an opportunity for people to get into technology without knowing code. You kids can learn how to imitate a task and teach a robot.
Yeah.
Elderly can use this technology and help build exoskeletons and age tech. So I think this AI layer really makes this technology democratized because of the language. You can talk to code in natural language.
And you
I
can
think,
code so much now so easily. I mean,
yeah.
what we did yesterday, and by we I mean Justin. So thank you, Justin. But
Yeah.
what we did yesterday in a matter of hours would have been 4 weeks, 6 weeks of like a research student's time just to get the infrastructure set. And now you can get so much done so fast. You got to know the right questions. You got to know how to guide a program. But I mean, the barriers are getting low very quick to
Yeah.
get into this
Yeah.
space.
And in addition, what I'm also realizing from this events is there's so much hunger for innovation.
Yeah.
The next generation really wants to do cool stuff, and this space allows them to unlock that, right? People can really come in here, and this is the only place where you can access 20 plus SO101 arms in one location. I think in the planet right now. So yeah, I think that sort of energy brings people together, and yeah, I think that is going to be the future with this also. I think the open source movement will allow us to train more intelligences, better intelligences, and I think that is the key to unlocking robotics for everyone.
Very
Yeah.
cool. All right, we're gonna do a break. I'm gonna grab the camera and we're gonna do the crib style home tour, and
Yeah.
let's go. So here we are again. Dhruv, tell us what you got here.
Yes. So, what we're trying to do with this space is get all the tools, right? So, this corner specifically is for inspiration. From the Iron Man suit and even the original Iron Man, mascot to, things that incite, ingenuity, engineering, to, the best robots and tools. We have everything. So, yeah, the point of this space is to basically be a puzzle, excitement like trigger, and we have robots of all kind. So it's an opportunity for someone to come in and just choose their favorite robot, either a drone or a flying thing or a crawling thing, and try to train it with the best AI tech. So yeah, that's what we want to allow. And this part is the inspiration section. This is all the tools on the planet. So this is another robot that we're training, which is probably going to give tours of this space soon. But yeah, we
So
ensure
this is the army of the what is it?
SO101.
SO101.
Yeah.
Yeah. So these are a huge collection of the robots and the trainers.
Yeah. And obviously we have all the hardware with the Jetson Nano and RealSense cameras and Mac Minis and basically the largest collection of SO101 arms anywhere on the planet.
And so what do we have here? The team this displays it looks it looks different every time I come in here. So what happened here?
Yes, we're constantly adding more robots and more stuff. So this is a station that we're building for stable data collection. So as you can imagine, in VLA training, you want your background and environment to be stable and reliable and good for data collection. So we built this out of Home Depot stuff, less than $10, and we're trying to have different versions of it so that we can open source it and allow people to also have these arms and collect data and train them in a sustainable and reliable way.
And so you can buy this arm from Hugging Face
From Amazon,
from Amazon
Seed Studio.
Seed Studio,
Yes.
and you 3D print the components, and it comes with the wires and motors here, and you get the full rig of the arm and the trainer. And with Solo, you can how does this work with Solo? So what do you do
Yep,
next?
you can set up it for teleop. You can start training and replaying your collected data, and you can also train a new movement that you want to record and play along with this robot, all in three lines of code. Yeah.
Well, I think we'll call it there for the home tour. Hold on, sorry for the selfie mode here. Typically people have more professional rigs than my phone, but this has been an awesome time with you, and we're really excited about the partnership and taking these VLAs to production.
Yes.
Anything you want to leave anybody with? How can they find you?
Yes, you can find our information on our website, getsolo.tech. We have a lot, and we have our Discord, which is exploding with new ideas, and you can find us on social media. And yeah, looking forward with all the work with Avocado OS and empowering the future of embedded world.
Absolutely.
Yes.
Thanks for coming on.
Thank you so much.
All right.